Okay, we're going to begin a discussion of long chain hydrocarbons. You'll find these in chapter 6, I believe. So as a continuation of our discussion on functional groups, we're going to talk about hydrocarbons. And the name implies that these are hydrated carbons. And by implication, you think of hydrated as being water. But in this case, we're simply talking about hydrogen. And hydrogen that saturates, or if you will, carbon. Okay, so we'll introduce the term saturation and unsaturation. And this has to do with the amount of hydrogen present on the carbon. So here we have a lot of memorization, simply memorization. You kind of have to get this in your spirit, if you will, when we talk about these hydrocarbons. The first group are referred to as alkanes. Okay, and their general structure for alkanes is a single bonded chain of carbons. Okay, again, the R stands for the continuation of these carbons, but they're all single bonded. And if I were to draw this out in a Lewis type structure, you'd see the hydrogens are represented, single bond to carbon. Okay, carbon has 4 bonds. You remember hydrogen is in group 1, so it has 1 valence electron to bind to another element. Carbon is in group 4A, so it has 4 valence electrons to bind to another group. And so we completely form the valence binding of carbon. And this is an alkane, single bonded. So now we have the context. Let's look at the next group, which are alkenes. Okay, alkenes, the same carbon chains. However, there is usually a double bond, or there is a double bond associated with the alkenes. Alright, again, hydrogen, 4 bonds to carbon. These are alkenes. Alkenes typically have a double bond, 1 or more. Alkynes are represented by a triple bond within the structure. Okay? So again, carbon has 1, 2, 3, 4 bonds, so its valence is complete. And we looked at ethers, and we looked at we didn't look at aldehydes. Aldehyde is in our group, carbonyl with a hydrogen. Okay, a ketone is in our group, a carbonyl and a methyl group. Okay? And remember, I referred to the carbonyl as CO. Okay, where am I? Right here. Sorry. Aldehydes, hydrogen, ketones with a methyl group. The carbonyl is typically a carbon with double bond to oxygen. It's oxygen. Alright. And this has properties involving electrons that will be important in biochemistry, as we should be seeing later on. Carboxylic acid. As a functional group. Here's the carbonyl again, plus a hydroxyl group. Okay, and these are, again, are part of the structure of proteins. It can act here as an acid, or you'll see the carbonyl written like this, or you'll see it written like that, or if it's protonated, it would be written like that. Those are all the same representation of a carboxylic acid. So let's look more closely at these alkanes and alkenes. There are certain properties associated with these organic. Actually, they're not really organic molecules, because what's an organic molecule? An organic molecule is one that contains at a minimum carbon, hydrogen, plus oxygen. Okay, so some of the functional groups we just saw have carbon, oxygen, and hydrogen, so they're considered organics. Alkanes, in the context that we're looking at, and alkenes are not technically organic, but they are components of organic compounds. So organic compounds contain, let's put this here, carbon, hydrogen, and oxygen at a minimum. So alkanes come in a variety of lengths, and they have specific names to designate those lengths. A methyl group is simply a single carbon. Alright? It's not a chain. An example, methanol would be CH3OH. Okay, so the methyl prefix is used to designate one carbon. Ethyl is two carbons. Okay, propyl. What do you think? 3 carbons. Butyl. And for the sake of time, I'm not going to write them out. 4 carbons. Pentyl. 5 carbons. Hexyl. Okay, 6 carbons. And so forth. We have hectyl, heptyl, 7 carbons. Octyl, what do you think? 8. Okay. And nano, nonyl would be 9, and of course decyl would be 10. And sometimes you'll see the designation CH2 parentheses CH2 and then 8 CH3. Okay, so we have 8, 9, and 10 carbons. These, let's see if I can, there we go, have physical properties that we did talk a little bit about. The shorter chains have a low boiling point and a low melting point. Alright, and as your chain length increases, you end up with a higher boiling point and a higher melting point. Also, these are what are referred to as saturated hydrocarbon chains. And what does saturated mean? It means that they have their full content of hydrogen. Alright, because in this chain we're looking at here, the 4 bonds to carbon would, well, we have 1 bond to some R group, carbon, 2 hydrogens, and then the next carbon and 2 hydrogens, and the next carbon and 2 hydrogens, all the way to the last carbon, which has 3 hydrogens. So this is completely saturated. When we talk about alkenes, we have the same nomenclature, except the suffix for these are usually ENE. Alright? And these, if I draw a propyl, CH2, C, double bond, C, that's 1, 2, 3, there is an H on it, CH3, 1, 2, 3, 4 carbons, this would be a butyl, and with the double bond, we call this butene. Okay. In the example above, this 10 carbon, if I had a functional group to terminate this long chain of 10 alkanes, it would be referred to as decane. Okay. Butene, T-E-N, because we have a double bond. And with the double bond, we lose 2 hydrogens, here and here. Alright? So that makes this long chain of butene unsaturated, because it lost some hydrogen. Could be 2, could be more. But anytime you lose hydrogen from the chain, it becomes unsaturated. And there are other properties associated with this double bond. But a saturated hydrocarbon chain is one that consists of all single bonds. Okay, single bonds. And an unsaturated hydrocarbon chain would have at least 1 double bond. Alright, so that's part of chapter 6. We'll talk about ring structures and structural isomers, stereoisomers in the next video. We'll talk to you later.